Hi, let us look at an example on how we apply the block diagram reduction techniques. So we are told to reduce the block diagram and find the transfer function of the system that is shown here. So in this case, I have this kind of a block diagram. It has the input, it has this block, the other block, it has the output. Then on the feedback path, we have two blocks like that. So the first step is always identifying the rule that will apply first. Identify the rule that you will apply first. And in this case, I have this block. You can see this arrow. Then I have this block G1 is coming toward this summing point. I have this block G2 coming toward this summing point. This one is positive, this other one is the negative. It means that because the two of them are coming towards this summing point, then these two blocks are in parallel to with each other. So I need to combine. So let us look at the solution. We can first combine the parallel block. This parallel block is positive G1 and minus G2, so that this one will give me G1 minus G2. Then after combining them, I'll just plot another diagram representing them in one block. So I will have my input R, I have my summing point like that. Then I just plot one block like this. I put my value. These two I have just combined them. That is G1 minus G2. Then I have that. Then I plot the other ones. This is a summing point like that. I have, this is block G3. Then I have, this is block G4 like that. This is my output C like that. So always ensure you indicate the arrows. Always ensure you indicate the arrows so that you can know the direction of a flow. Then from there, now I look at the diagram again. Then when I look at my diagram here, this was positive, this was negative. You can see that I have block G3 coming towards this summing point, and I have block G4 coming towards the same summing point. Still, it means that these two blocks are in parallel with each other, so I can just combine them by summing the two of them. So I can combine the parallel blocks. I can combine the parallel blocks like that, so that I will have, this is G3 is positive, so we'll have G3 minus G4, because G4 you can see it is negative. Then after doing that, I will still plot another diagram representing the two of them under one block. So I'll just plot my diagram like this. This is the input R. I have the summing point here. Then I indicate my arrow. I have this block here that has G1 minus G2. Then I have this other block here that has a G3 minus G4. Because the two of them were in parallel, we just sum them up. We get that as the answer after combining the two of them. That's what we have. So you can see that I have only one block in the forward path. This is my block in the forward path. Then when I reach at this point, you see that I have a feedback path. So the feedback element here is G3, G4, and I still have the one block in my feedback path. So now this one becomes my canonical diagram, because I have only one block in the forward path and one block in the feedback path. I have the output C and the input R. So then from there, I can now obtain the transfer function of this system. The transfer function is the same as the control ratio. So this transfer function, C over R, is given by G over 1 plus or minus GH. That's what we have. Then you find that this element is whatever we have in the forward path. And in our case, what we have in the forward path is a G1 minus G2 divided by 1 plus or minus. This G is what we have in the forward path, which is G1 minus G2. Then we have this one is multiplication, so times H is what we have in the feedback path, and in our case we had G3 minus G4, like that. So this C over R is the same as G1 minus G2 over 1 plus or minus this is a G1 minus G2, can put in bracket, then G3 minus G4. That becomes our control ratio. You can still expand this one, but you reach that point, you still have your answers. So that's how we apply the block diagram reduction techniques to obtain the unknown parameters. You can watch my next video for the next example. Thank you so much for watching, and please subscribe for me.